Reviewing some of the concepts that we talked about in class the other day with optimization. So optimization is we're looking for a maximum or minimum, usually one or the other, although math problems will sometimes ask you for both. But it would make more sense if you're talking about a company's profits, you want to maximize it. If you have to meet a certain production goal, you want to minimize expenses. So usually one or the other, but for completion we'll talk about both. For some function f of x. And generally it's constrained. So a is less than or equal to x less than b. X has to be in between a and b. First off, I want to discuss what we can mean when we talk about max and mins. Local max and mins are max and mins in their little area. So both of these possible examples here have local maxes and mins. This is a local max. In its little zone right around it, it's certainly the maximum point. But for the totality between a and b, it's not the max. We have an endpoint that's actually generating your max. Whereas over here, this local max, so max in its area, actually will be the global max as well for A to B. And similarly for mins, we have a local min here, but the endpoint actually has a lower value. And over here we have a local min that is also the global min. So we've got these terms defined. And these are two possible different examples we could be looking at. Okay, we're going to find critical points for a function. And critical points are defined to be the following. Points where either the derivative is 0, as we can see that generated a max and a min in this case. While it wasn't a global max or min, it was a local max or min here as well. Derivative being the tangent, we have derivative of 0 right here. Also points where the derivative is undefined. Doesn't show up in either of these two examples and isn't terribly common in real world problems either. But those are other ones of concern. And then the endpoints. So that's our set of critical points. Now notice that for both of these graphs, we have the same 4 critical points. The endpoints A and B, and the points C and D where the derivative is 0. Similarly here, the endpoints A and B, and the points C and D where the derivative of the function is 0. So they have the same set of critical points, but a different result. In this case, the absolute maximum occurred here at B. Over here, our absolute maximum occurred here at C. So we can see that to find a maximum on a function between A and B, we have to check the points where the derivative is 0 and the endpoints. We can't be sure just checking the derivative. And similarly for the min point, here the minimum point would be A. It's the lowest f value between A and B. Over here it would be D. So the derivative equal to 0 generates our minimum point here, whereas here was the actual endpoint. We can't forget the endpoints in this analysis.